Alright, so we're gonna solve this fucking problem that has taken me 3 hours to fucking understand. So it's basically saying that in this figure we have fucking Sammy over here, and he's skiing. And he's skiing downhill on an incline of 10 degrees, like we see right here. And he has a rope attached to him at a 30-degree angle. And the whole question is asking us to find the rope with all these dumbass conditions. But before we attack this problem, we're gonna go over some basic knowledge, things we should know beforehand. For example, we know that in Newton's second law, it says that the net force of everything should equal zero unless there's acceleration, right? So what does that mean? It's basically stating that every force should cancel itself out unless there's an external force being acted upon it. So, just a brief example. Let's say if I'm going 1 meter per second at a constant rate, there's a force going against me at 1 meter per second, canceling my whole entire force, my net force, to zero. But if I accelerated, let's say 2 meters per second, then that would mean that for every second that passes by, I'm going 2 meters faster, minus the 1 meter per second, which would change the value of zero now. Okay? I hope you're getting this. So now that we've established that rule, let's go to a second thing. The equation to this whole entire problem is friction force minus the sine of 10 minus t cosine of 30 equals 0.4 mass times gravity. Now you might be asking yourself, what the fuck did this nigga just say? And I completely get that, because that was me. But I'm going to explain this. Fn stands for frictional force, which we were given. You see, Sammy, throughout this whole entire time, is having a frictional force of 0.1 going against him. You might ask yourself, what is frictional force? Well, the equation for frictional force is that it states that for every the coefficient, in this case is 0.1, is basically the friction over the normal force. Or in other words, it's your normal force. So if you're going 60, right? If you weigh 60 kilograms, like Sammy, and you have gravity acting upon yourself, which we all know is 9.8 meters per second, it'll come out to, I don't fucking know. We're going to say 600. That's your normal force, right? Now, if you times your normal force by this right here, this coefficient, you will get your frictional force. And the frictional force, 600 by 0.1, is 60. Okay? So now we have established that you have a frictional force of 60 newtons going against you. Sine of 10. This seems like a random number to put out, right? But it's really not. Because if we look at the picture, we can see that Sammy is in an incline of 10 degrees. And this means that he doesn't actually weigh 60 kilograms. He weighs different from 60 kilograms. So what do you do to find that? Well, you find sine, right? You might say, why is that? Well, this is why. He might weigh 60 kilograms on a regular platform, but when he is inclined, his weight is distributed unproportionally, giving it a false sense of weight. So you have to times it by sine of 10, which is the angle, to get his actual weight. And if you times that amount by gravity, then you'll get his force that's being pushed down upon him. And then t cosine of 30, this t stands for tension. And cosine of 30 is us simply trying to find, you see this angle right here? 30? We're not trying to find this. This is the hypotenuse. We're trying to find the rope, which is actually here. And to get that, we have to do cosine. So now we go back to our equation. We're saying that the frictional force minus the actual weight, which is sine of 10, minus the tension of the rope equals 0.4 mass times gravity. Now you might say, where the fuck did 0.4 come from? 0.4 comes from his acceleration. Because, as I explained in the beginning of the video, your net force will always be 0 unless you have an acceleration. And if you have an acceleration, it doesn't mean that your net force becomes your acceleration. No. It means your net force becomes your acceleration times however fast you were going. Your force. So, that's why we wrote mass times gravity. As you see there. So now, all we have to do is look at this. This is the most important part of this. Friction is always occurring. What do I mean by that? What I mean is that it's affecting everything. And if it's affecting everything, then you have to basically multiply this whole entire equation by friction, because it's affecting everything. So, I really hope that you got that. We're going to rewrite this equation. We're going to manipulate it in order to find T. So we're going to say that tension, right, is equal to 60, which is the mass of Sammy, times 9.8, which is gravity, okay? And this number, I didn't bring it out of my ass. This number, 60 times 9.8, is this number, mass times gravity. And we're going to say, we're going to multiply it to everything. When I mean everything, I mean to the acceleration plus sine of 10. And this makes sense because we said we were trying to find sine of 10, his actual weight. In order to find his actual weight, we had to multiply his mass regardless. Sine of 10 plus 0.1 of cosine of 10. And the 0.1 is friction. Friction on Sammy right here. Because the rope is also feeling the friction of him, of Sammy, on the snow. So we have to multiply it by 0.1. And once you get this number, you divide this number by 10. My bad, I'm sorry. By cosine 30 plus 0.1 sine of 30. And I'm going to explain why. The cosine of 30, as I said, this is the hypotenuse. We're trying to find the tension, which would be this layer, right? That makes sense. But we also have to remember, like I said, friction is still acting upon Sammy. So we also have to find the sine and add to it. Because if we don't do that, we'll get some wonky number that will go against this whole entire equation, because we're basically saying that, oh, the rope is not feeling the friction that's occurring on Sammy. If we were like, for example, if I was just to times it without the friction, then the number I would get here would be a number that would only be true if there was no friction occurring on Sammy. So after you do that, you would get like 431 point some wild ass number. But it's this, and that's the important part. So to recap, okay, net force is 0 unless you have an acceleration. If you have an acceleration, then this whole entire thing changes. This is the equation for tension. friction force by sine 10 to t cosine 30 in this problem. But normally, the tension formula is tension is equal to mass of 1, or mass, it doesn't really matter, and you times this by acceleration plus the force of gravity. Number 3, friction is always occurring. And here.